All right, 2.1, we're going to talk about quadratic functions and their graphs. So a quadratic function is an x squared function. What shape does an x squared graph have? A parabola. So first page just talks about kind of the background of it. In this chapter, we'll deal with polynomial functions. So poly means many, so we'll have many terms. But just in this section, in 2.1, we're going to focus on quadratic functions, which are just x squared. So we'll get to higher degrees later on this chapter, on Monday. So these are examples of quadratic functions. So quadratic functions have x squared, whether it's just an x squared, or we have parentheses that are squared, or if we have x times x, which would give us an x squared. So these are just examples of quadratic functions. They could look like any one of these. So it doesn't really give a name for, this is kind of standard form of a quadratic function. It's not really standard form because they have a different standard form, but this is just like the basic form of our quadratic function. We have a times x squared plus b times x plus c. So the number in front of the x squared is our a, the number in front of the x is b, and then our constant is c. So if our a is positive, meaning the number in front of the x squared is positive, our graph is going to open upwards. The vertex is going to be at the lowest point, which means that we have a minimum value. And then our axis of symmetry just goes right through the vertex. Now if a is negative, then our parabola opens down. Our vertex is now at the highest point, which means we're going to have a maximum value. And same thing, our axis of symmetry goes right through the vertex, right through the middle. Axis of symmetry acts as a mirror, so whatever we have on the left side of our graph, we've got the same thing on the right side of that axis of symmetry. Next page just says the same thing. When a is greater than 0, so meaning it's positive, our graph opens upward. When a is negative, it opens downward. And then the simplest type of quadratic function is just a times x squared, where the vertex is at 0, 0. We're going to be dealing with more than just x squared. We'll have x squared plus a number, plus another number. More things where it's not just a basic parabola. But this would be our parent function. This, again, just talks about the maximum, minimum, and minimum. If our vertex is at the lowest point, we've got a minimum. If vertex is at the highest point, we've got a maximum. And our max and min is always the y value. In example 1, to sketch the graph of the function and compare it with the graph of x squared. So our x squared is just our parent function. Our vertex would be at 0, 0. We can plug in a couple points just to get a good idea of the shape of our graph. If I plugged in 1 for x, what would our y be? 1. If I plugged in 2, what's our y? 4. 2 squared would be 4. And then we have the same points on the negative side too. So this would be our parent function for the parabola. So now in graphing A, B, C, and D, you can either just graph it by applying your transformations, which we talked about our transformations in the last chapter, so we know what way our graphs move, or you can plug in points to see where your graph's going to go. But it helps to know your transformations. For A, if we have a negative being multiplied to x, what way does that move our graph? What does that do to our graph? A reflection on the x-axis. What about if we add 1? Up 1. So we're going to do a reflection on the x-axis and then shift it up 1. So it's now going to open down, but we shift it up 1. So this would be our new parabola. That would be A. Now let's do B. When we add 2 on the inside, which way does that move our graph? Left 2. And subtract 3 on the outside? Down 3. Is our parabola going to open up or down? Up. Our A is positive. We don't have a negative out front. And we don't have any reflections here. So we just shift it to the left 2 and down 3. And the parabola keeps the same shape as the red one that we had. It opens up. All right, now for C, when we multiply by 1/3, now this is outside of our x squared term. So when it's outside, it's a vertical. Is it stretch or shrink? Shrink. Because it's less than 1, it's a vertical shrink. So think about if you had a rubber ball and you were shrinking it down vertically, so compressing it down vertically, it'd make it wider quicker. If you want to plug in points to get more of an idea of how wide this is going to be, let's do it. Our vertex stays at 0, 0. When I plug in 1 for x, what's the y? 1/3. When I plug in 2, 2 squared would be 4 times 1/3 is 4/3. Or 1 1/3. So our graph would look like this. So it'd go a little bit wider than that original parent function. And then when I multiply by 2 on the outside, we have a vertical, what? Stretch. So we're stretching our graph vertically, so it's going to get skinnier quicker here. So my vertex is still at 0, 0. If I plugged in 1, 1 squared is 1 times 2 would be 2. If I plugged in 2, 2 squared is 4 times 2 would be 8. Then we have the same points on the other side, so at -1, 2, and -2, 8. So this would be 2x squared. So you can apply your transformations or just plug in values to see the shape of your graph. Now, so our book says that this is standard form, but some books call this vertex form because it's when it's in this form that a times x minus h squared plus k, you can clearly identify what your vertex is. So sometimes this is called vertex form, but this book calls it standard form. But we have h and k as our vertex. So vertex is the point h, comma, k. Where we always change the sign of the h. So notice how it's x minus h. When we're naming the point for our vertex, you always change the sign. So if I had something like 2 times x plus 4 squared minus 10, what would our vertex be? Awesome. -4, -10. Perfect. Now in example 2, we're going to write the standard form. So that's technically our vertex form, where it's y equals a times x minus h squared plus k. And sketch the graph and identify the vertex of the parabola. So there's 2 different ways that we can do this. One way is we can complete the square. The other way is we can find the vertex and then just plug that into our standard form. I'm going to do it by completing the square to show you guys. I think that finding the vertex is easier, but you can do it however you want, whatever way you like better. If you enjoy completing the square, do that. So to complete the square, I'm going to separate my x terms. So I've got 2x squared plus 8x. I'm going to leave a space to complete the square and then just leave that plus 7 on the outside. So I didn't really do anything yet. I just put a gap in my function here. What would we do first to complete the square? We can move it to the other side, but that would be like if we were solving, you'd want to move the 7 to the other side. Here we're just rearranging the right side of our function. So I'm going to leave it there. What would we do to complete the square? I'm going to take the 2 out. We need the leading coefficient, the term in front of the x squared, to be 1. So I'm going to take the 2 out. So I'm going to divide both of the numbers inside my parentheses by 2. Take it on the outside. So I'm left with x squared plus 4x. I'll leave a space there, plus 7. What's the little formula we use to complete the square? Awesome. B over 2 squared. So our b would be 4. So this is 4 over 2 squared. And 4 over 2 would simplify to what? 2. So we have 2 squared. Now I'm just putting this 2 squared into my equation out of nowhere. So I got to make sure I keep my equation balanced. So here I actually have 2 squared would be 4. So what would I need to do to balance my equation? I got to add it to the outside, or I'm technically adding it on the inside. But before I add it, what would I need to do? Well, we squared it, we got 4. Multiply it by 2. If you took a number out front, you got to make sure you multiply it to that number. So this is not just 4, it's actually 8. So I'm adding 8 inside here. What would I need to do to keep my equation balanced? Awesome. I would subtract 8 from the outside because we're working with the same side of the equation. So since I'm adding 8 on this side, I also need to subtract 8 on this side. It was a little bit different when we did it in the pre-chapter because we were solving. So I would add 8 on one side. I had to add 8 on the other side too. But here we're just dealing with one side of the equation. So now I'm going to complete the square. So 2 stays on the outside. The squared term and the squared term go inside my parentheses squared. So x plus 2. And then 7 minus 8 would be negative 1. So this is our function in standard form. Again, we're not solving, it just asked us to put it in standard form. So we just completed the square to rearrange how it looks. Now that it's in standard form, we can clearly identify our vertex. What's our vertex? Awesome, -2, -1. What's our axis of symmetry? Awesome, x equals -2. So let's graph that. I'm going to put a point at -2, -1. Our axis of symmetry is a vertical line that goes right through the vertex. So that's how we get the x equals -2. It's got to be x equals because it's a vertical line. So x equals -2. Now to find another point on our parabola to get an exact graph of how our parabola looks, what could we do? How do I find another point on my parabola? I can plug in a number into x to find y. What would I plug into x? I mean, we can really plug in anything except -2 because we already have that point. But what would be a good number to plug in? 0. You could plug in -1. That would work. But 0 is going to be a little bit easier to do the math with. If I plugged in 0 into my original equation up here, we'd have 2 times 0 squared plus 8 times 0 plus 7. What do we get? 7. So when we plug in 0 into the x, we actually get the y-intercept, which would be 0, 7. So we cross the y-axis at 7. Remember, our axis of symmetry acts as a mirror, so if I have that point 2 spaces away on the right, I'm going to have the same thing 2 spaces away on the left. And I can graph my parabola. Yes?
On the test, is it going to ask us to do it one way or another, or can you just
Do it however you want. So this is the second way how we find the vertex. The first way was completing the square. You guys can do it however you want. It doesn't matter to me if you like completing the square. I think it's easier to find the vertex. That's how I teach it in pre-calc. But if you guys are comfortable with completing the square, do it that way too. Next page talks about how we can find the vertex. If it's in that a times x squared plus b times x plus c form, we can put it into our standard form by using this formula to find the vertex. So that's negative b over 2a. That's how we can find the h in our vertex. And then to find the k, we'd find f of negative b over 2a. So we use negative b over 2a to find the h, and then to find the k, we'd plug in that number. Plug in and solve. So I'm going to go back to that last example and do it this way. Next page talks about finding the maximum and minimum values. So when a is greater than 0, so meaning that it's a positive a, our graph opens up, so our vertex is at the minimum. The minimum value is the k from our vertex. So it's f of negative b over 2a, which is just the k from our vertex. Same thing when it's negative. Our graph opens down, which means that we have a maximum at the vertex. The maximum value is the k. In example 3, it expects you to have a graphing calculator to do this, but I'm just going to kind of like talk you through it just to get an idea of like what's what for word problems. So it says a baseball is hit at a point 3 feet above ground and above the ground at a velocity of 100 feet per second and at an angle of 45 degrees. With respect to the ground, the path of the baseball is given by the function negative 0.0032 x squared plus x plus 3, where f of x is the height of the baseball in feet and x is the horizontal distance from home plate in feet. What's the maximum height reached by the baseball? When does the baseball strike the ground? So I'm going to draw it kind of. So it's hit at a point 3 feet above ground, so we start at 3 feet above ground. And it's going to have that shape of a parabola. We hit a baseball, it's going to go up in the air, and then it's going to hit the ground. So when it says, what is the maximum height reached by the baseball? That's going to be at our vertex. And that would be our k. So the max would be the k from the vertex. So again, it expects you to use a graphing calculator here and graph it, find the k on the calculator. We'll get into doing that later, but not yet. No calculators yet. And then when does the baseball strike the ground? At what part of our graph would the baseball strike the ground? The x-intercept, awesome. So our x-intercept over on the right side would be when the baseball hits the ground. I'm going to do a couple more questions with you guys that you'll see questions like this on the homework. So just to kind of practice what you'll see from the homework. There's one type of question where it gives you the vertex and a point on your parabola. So let's say our vertex was 1, 2, and the point on our parabola was 5, 4. And it asks you to come up with the standard form equation. Standard form. So our standard form is y equals a times x minus h squared plus k. So our vertex is our h and k. Our point would be the x and y. From our equation here, what are we missing? What do we not have? A. So that's what we need to find. So I'm going to plug in everything I have and we're going to solve for a. So I have 4 equals a times x minus h, so 5 minus 1 squared plus 2. And just solve for a. I'm going to subtract 2 on both sides. We get 2 equals 5 minus 1 would be 4 squared is 16, so 16a. Divide by 16. A equals what? 1 over 8. So when we plug that in, we are going to plug in our a, h, and k. So y equals 1 over 8 times x minus 1 squared plus 2. All right, the other type of question that you'll see that we didn't really practice would be finding the x-intercepts. So if I had something like f of x equals x squared plus x minus 30, and it asks us for the x-intercepts, what would I do? We set it equal to 0, so I would change the y to be 0. And then we'd have to factor. What are 2 factors of negative 30 that add to 1? 6 and negative 5. Perfect. So x minus 6, or x plus 6, x minus 5. So x equals negative 6 and 5. X-intercepts are going to be points. How would I write this as a point? Negative 6, 0. What do we plug in for the y? 0. So it'd be negative 6 comma 0 and 5 comma 0. So to find the x-intercepts, plug in 0 for y. What about for the y-intercepts? What do? Plug in 0 for x. What would our y-intercept be here as a point? 0 comma negative 30. We plugged in 0 for x, so 0 is going to go in the x spot. And then when we plug in 0, we get 0 plus 0 minus 30. So it'd be negative 30. Your C is always going to be the y-intercept.